Good morning, everyone. Today we are covering Chapter 4, Making Decisions. This deals with the switches, the if statement, the if-else statement, and the main-driven programs, nested if statement, logical operators, validating user inputs, more about block and scope, more about characters and string, the conditional operators, the switch statement, the enumerated data types. To start with that, let's start with the use relational operators. They are used to compare numeric values to determine if relative order. Values to determine relative order. So operators include greater than sign, less than sign, greater than or equal to, the less than or equal to, the equal to, and the not equal to. These are similar to what you have learned in math as well. Relational expressions are Boolean, evaluates true or false. So for example, is 12 greater than 5? What you get is true. Is 7 less than or equal to 5? What you get is false. If x is 10, then x equal to here is equal to 10 is true. X less than or equal to 8 is false. X is not equal to 8 is true. And x equal to 8 is false. Can be assigned to variables. So Boolean result equals x less than or equal to y. So assigns 0 for false, 1 for true. So do not confuse the assignment with the equal to. Assignment, we discussed this before, it's basically one equal sign, and then the two equals is the one that represents the equal to. Okay, so one is to initialize something, you're assigning a value to the one on the left, while the other one you're saying this is the exact value it equals to. And you can look at the examples on page 158. The if statement supports the use of a division structure, so allows statements to be conditionally executed or skipped over. So models for the way we mentally evaluate situations. If it's called outside, then wear a coat and wear a hat. So this is a single if statement. So here is how it's written. If the condition, again, the way you write it, you have if, then the parentheses, there is no semicolon. And then you put the statements in. So the block inside the brace is called the body of the if statement. If there's only one statement in the body, then the braces may be omitted. But it's always better for good programming to keep the braces. Okay. In Python class, you have learned that we didn't use any braces. It was more of just tabs. Okay. But for other high-level language, they all use braces. The if condition is true, then the statement in the body are executed. If condition is false, then it will go to the next one. Then the statements are skipped. And there are examples that are also on page 162. I'll show you one. So this is the flow chart of it. So if condition, then it's checked. If it's false, it keeps whatever that's inside, then exits the if statement, exits that block. If it's true, one or more statements, whatever that's in there will be executed. So for example, if statement, if score is greater than or equal to 60, then you say you passed, then they end the line. If a score is greater than 90, then grade is A. See out, wonderful job, and so forth. If is a keyword, so it must be lowercase. Condition must be inside the parentheses, kind of like a function. Do not place a semicolon after the condition. And don't forget the braces around a multi-statement body. Place each statement on separate line after a condition. So indent each statement in the body. So when using the braces around the body, put the braces on the lines by themselves. You don't have to do it, but it's good programming. Does that make sense? So what is true and false? So an expression whose value is 0 is considered false. An expression whose value is non-zero is considered true. An expression need not be a comparison. It can be a single variable or a mathematical expression. A flag is a variable that signals a condition, so usually implemented as a Boolean. So meaning true, the conditions exist. False, the condition doesn't exist. So the flag value can be both set and tested with an if statement. So Boolean condition here, if Boolean valid months is true, then if months is less than 0, valid months equals false. If valid months, so month payment equals total divided by months. You can have an integer flags. So integer flags, integer variable can be used as flags. Remember that 0 means false. Any other value means true. Okay. Again, when you see these examples, try to copy it and basically paste it and run it. So the if-else statement allows a choice between statements depending on whether the condition is true or false. So format if condition, then statement 1, else the next statement, and so forth. We have an example on page 170. So the example we have seen earlier about if it rains outside, then it was what? Take your umbrella or the tech coat, right? So that was just a single. So here, then you can give it another choice. You can say else, go on with your normal day, whatever you used to do. That makes sense? Else, wear something light, so whatever you want to say. So you can give it a choice. And you can have multiple else's. So if condition is true, statement set 1 is executed and statement set 2 is skipped. If condition is false, statement set 1 is skipped and statement set 2 is executed. I'll show you an example of that on page 171. You can see one there. So here you have the condition. If it's false, statement 2 is executed. If it's true, statement 1 is executed. And then it would exit. So in the case, let's say if it was true that it rained, then statement 1, let's say take your code, would be executed. If it was false that it didn't rain, then statement 2 would be executed, which is go on with your normal day, whatever other message that you had. Okay. So if a score is greater than or equal to 60, you passed, else, say you didn't pass. If integer rate or interest rate, whatever that stands for, is greater than 0, then in this case it would be interest rate, then it would be interest equals loan amount times the interest rate. See out, interest. Else, see out, you owe no interest. Comparison with the following numbers. So you have, it's difficult to test for equality when working with floating point numbers, so it's better to use greater than or less than test, or test to see if the value is very close to a given value. Chain of if statements that test in order until 1 is found to be true. So also Morrow's thought process. If it's raining, take an umbrella. Else, if it's windy, take a hat. Else, if it's sunny, take sunglasses. Else, if you're not in the mood, don't do anything. Right? So you can list them like that. Yeah. Use with if-else, if statement when all of the conditions are false, provides a default statement or action that is performed when none of the conditions are true. It can be used to catch invalid values or handle other exceptional situations. So here you have with the trailing else's, if age is greater than or equal to 20, see out, you're an adult. Else, if age is greater than 13, see out, you're a teen. Else, if age is greater than or equal to 2, see out, you're a child. Else, see out, a baby. Kind of like the default here. Kind of like the do nothing part of it. Then you have the menu-driven program. So menu is a list of choices presented to the user on the computer screen. Sometimes you see it as a drop-down, okay, or as a checkbox. So menu-driven programs program execute controlled by user selecting from a list of actions. So menu can be implemented using if-else statements. And for the web development, sometimes you see it used with JavaScript and HTML to combine together. So display list of numbered or letter choices for actions, input user selection of a number or a letter, test the user selection in condition. If match, then execute code to carry out the desired action. If not, then test with the condition, with the next condition. You can have a nested if statement, an if statement that is part of the if or else part of another if statement. It can be used to evaluate greater than the item of condition. So here you have if the score is less than 100, then if the score is greater than 90, grade equals A. Else, see out, grade is not an A. Or you can see out another else, whatever else you want to say. An else matches the nearest previous if that does not have an else. Okay, so here you have if, this score, and then here you have this would be, this else goes with this one. Okay, not the first one. That's why we had the other else outside in the previous screen. So proper indentation aids comprehension. Then we have what's called logical operators. So used to create a relational expression from other relational expressions. So you have the operator, the 2 ampersand means and, so new relational expression is true if both expressions are true. You have the or the two vertical lines. So this means or, so new relational expression is true if either expression is true. And then you have the not, the exclamation mark, which is the not, reverses the value of an expression. True expression becomes false, false expression becomes true. So these two statements to be true, for example, if a statement is to be true, let's say to get a scholarship, you need to be a resident of this county and you need to be majoring in computer science, let's say. Now you're filling out a form, and if the form says, are you a resident of this county? And you check yes. And then the next question is, are you a computer science major? And you check yes. If both become true, then because you selected both of them as yes, then you will get the scholarship. So this is an example of the 2 ampersand, the and. The or would be either or. So let's say, are you a resident of this county? You could say no, and then it will check the next one. Are you majoring in computer science? Yes. Then because you got one of them right, then it will still be true because it will give you a check. Does that make sense? But if both of them become false, you're not a resident of the county, you're not a computer science major, then it will become false because you didn't get both of them. You just here, with the or, you just needed to get one of them. This is the opposite. You say, I'm a computer science major, and then you see out, it will be because it's a not, it will say, no, you're not a computer science major. It will be the opposite of it. Okay. So here's an example of truth table, two expressions. True and true will be true. So true and a false will be a false. Remember, for ampersand, both of them must be true. Okay, so think of it as county resident, not a computer science major. Then false, you don't get it. Does that make sense? Then false, the same thing, you're just putting one over the other. Not county resident, but a computer science major. So it will be false. So basically false and true would be false. False and false will be false. This is not math. You don't say a negative and a negative will make a positive. You don't say that. Does that make sense? So false and a false is a false. So here you will see, so we discussed this, the two expressions. So this is with the or, okay? So true and a true will be true, and then true or, not and, true or a true will be a true. True or a false will be a true. You just need to get one of them right. So a false or a true will be true. And a false or a false will be false. It doesn't make to be true, okay? And then some example of the logical operators. So here, if x is 2 and y is 5 and z is 4, let's say. So here, x less than or equal to z. X is 2 and z is negative 4. Is this true? Huh? No. This is not true, so that means this is false. Now here we have or. Here it says y is equal to z. False and false will be what? False. You see that? Well, let's go back to the first one. Here you have x is 2 and y is 5. Is x greater than 5? No. Then we can ignore this using short circuit because we have an and here. Okay. By the way, we have what's called a short circuit. With the and, if one of them fails, you don't need to check the other. Does that make sense? So, and then z here is negative 4. We are saying z is greater than 5. So this is false also. So even if you check both of them, then it should be false. Now let's go back to the last one, the third one. X is 2 and y is negative 4. So is 2 less than negative 4? Z is negative 4. No, so this is false already. But since it's an or, we can still check the next one. Here it says y is not equal to z. This is a true statement. So because this is an or, and here we have a true statement, then this will become what? True. Here we have the opposite, right? Not. We are saying not. Now x is 2, and we're saying 2 is greater than negative 4. That's true statement. This is true statement, but because we are saying not, it negates it. Therefore, this will give us what? False. And then we have logical precedence. So this is the highest, and then the and then we have the or. So an example here. So here you have 2 less than 3, or then you have 5 is greater than 6, and 5 is, and so we have to deal with this first. So 5 is greater than 6, so this will be what? false, right? And then we are saying and 7 is greater than, which is false. So here in this box we get what? False. But we have an or. Is 2 less than 3? Yes, so because this is true and this is false and we have an or, it's true because and is evaluated for or. Right? And then you can say more on precedence, so arithmetic operators, then the relational operators you deal within the logical operators. Again, here we have an or. So here you have 2 plus 7 is what? 9. Is 8 less than 9? So this is true. So we have a true, and then here we have an or. Is 5 equal to 6? No, so this is false. This is true, this is false, but we have an or, so this will be true. Okay. Checking numeric ranges with the logical operator, so used to test if a value is within a range. So if a grade is greater than or equal to 0, and grade is less than or equal to 100, see out a valid grade. So this is your checking, right? It's a range. You can also test if a value lies outside of a range. So if grade is less than 0 or grade is greater than 100, it's an invalid grade. But you cannot use mathematical notations if 0 is less than grade or grade is less than or equal to 100. This doesn't work. Remember, we need the variable to be on our left side. And you can look at some of these examples. You can validate user input validation, and inspecting input data to determine if it's acceptable. So you want to avoid accepting bad input. You can perform various tests. You can use a range. You can use reasonableness. You can use valid many choices. You can use 0 as a divisor. Okay. And then more about blocks and scope. The scope of a variable is the block in which it's defined from the point of definition to the end of the block. Variables are usually defined at the beginning of a function. They may instead be defined close to the place where they are first used. Did we discuss scope when we were discussing about variables?
No.
Okay. I didn't discuss about somebody standing outside of the window, and so that's basically the scope. So let's say I have a variable named Ali, and that Ali is in this classroom. Because we defined it in here, we have access to that variable, correct? But the next classroom, they can have another variable named Ali, and they have access to theirs, okay? We have access to the one we have in our block here, and they have access to the one that's defined in theirs. But how about if somebody's standing in the hallway, midway point, and they can see it, and we can see it, so that'll be a global variable. So we have access to both of us, okay? So the scope is a variable, is the block in which it's defined, from the point of definition to the end of the block. Because it's defined in this block, we have access to it. Because it's defined in their classroom, they have access to it in their block. But if it was outside of both of us, but we can both see it, this would be considered to be global, so we have access to it.
It's like when you make a block and you define it on top, it can be used for the whole.
So if you define it on top of your program,
yeah,
then you can use it everywhere. This would be global variable.
Okay, so but if you define it
inside a function
block,
or inside a block, so it's only accessible within that scope. Yeah. You know how people say it's not in my scope?
Yeah.
Then it's like I don't have access to it.
Okay.
So if it's in your block, then you have access to it.
Okay.
Does that make sense?
Yeah.
So variables defined inside those braces have a local block scope. Remember how I said the other one is global. So this would be what? The local. So when in a block that is nested inside another block, you can define variables within the same name as in the outer block. Even though we're in the same program, I told you if it's in this classroom, so that would be like, let's say it was a function, then they have access to theirs, we have access to ours, we can have the same name, okay? You can define variables with the same name because we are different. But if it's outside, then I cannot define it the same, okay? But because it's outside, we do have access to it. So when the program is executing in the inner block, the outer definition is not available. This is generally not a good idea, okay? You can use relational operators with characters and string objects. So if menu choice equals A, if first name equals Beth, and so forth. Comparing characters is really comparing ASCII values of characters. Okay, comparing string objects is comparing the ASCII values of the characters in the string. So comparison is character by character. You cannot compare C-style string with relational operators. Look at some of the examples on those pages. And testing characters, bless you. So it requires CC type header file, kind of like we have the IO stream. So these are some built-in functions you can use. So is alpha would be true if argument is a letter, false otherwise. Is alpha numeric true if argument is a letter or a digit, false otherwise. Is digit true if an argument is between 0 and 9, false otherwise. Is lower true if an argument is a lowercase letter. So these are some built-in functions that you can use. Some character testing requires the CC type header file. Is print true if an argument is printable character, false otherwise. Is true if argument is punctuation character, and so these are some built-in. It's uppercase, it's lower, also other built-in functions you can use with a string. You can use to create a short if-else statement. So format, you can write if, so this expression with a question mark expression and then colon and expression. So the first expression condition is tested, you have the question mark. Then the second condition expression executes if the condition is true, otherwise third expression executes if the condition is false. So this is shorthand format you can write. Some more examples you will see on page 208 and 209. Then we have the switch statement. So it's used to select among statements from several alternatives. You may sometimes be used instead of if-else statement. It's another option. Okay. Again, you have a choice using either or. So here you have a switch, and then whatever the expression is, the initial expression, and then the cases. Case, expression, and then a statement. 1, case, expression, 2, statement 2, and so forth. Okay. The initial expression must be a character or an integer variable or an expression that evaluates an integer value. So expression 1 through expression n must be constant integer type. Expressions must be unique in the switch statement. Default is optional but recommended. So the first expression is evaluated, then the value of int expression is compared against what is inside the block. Okay, expression 1 through expression n. So if there is a match, then the program branches to that statement following that expression and continues to the end of the switch. If no matching value is found, then the program branches to statements after the default. You have the break statement used to stop execution in the current block. It's also used to exit a switch statement. So useful to execute a single case statement without executing statements following it. So an example of that, so you can have a switch and then you define it as gender. So if the case F is selected, see out a female, and then you can break out. Then if the case M is selected, then see out is a male, you can break out, then the default will be invalid gender. So a switch statement is a natural choice for menu-driven program. So you display a menu, get user input, use user input as integer expression in switch statement, use menu choice as expression to test against in the case statement. Enumerated data types, data type created by a programmer, so it contains a set of named constant integers. So you can have enum, name, and then the values. Okay. You set it as a set, kind of like a dictionary type, which we will discuss later. The enum fruit, you can have apple, grape, orange. Enum days, Monday, Tuesday, Wednesday, and so forth. So to define variables, use the enumerated data type name, so fruit, snack, and then days, work day, vacation day, and so forth. Variable may contain any valid value for the data type. So enumerated data type values are associated with integers starting at 0. So similar to arrays. So the first one is a 0, the second one is a 1, and so forth. You can override the default association. So instead of 0, you can say apple is in position 2, grape is 4, orange is 5, and so forth. So enumerated data types improve the readability of a program and cannot be used with input statements such as sin. So will not display the name associated with the value of an enumerated data type if used with a cout. So let's see some examples. So maybe a quick statement. So let's say let's declare integer, and let's say we are trying to understand the score, integer score, and then maybe print for the user. Can you guys see? If we see out, and I say something like enter your grade. Then the user enters their grade. And then we try to understand that grade. So we will try an if statement. So we say if the score is greater than or equal to, well, you can say greater than, greater or equal to, whichever you pick. Okay. 90. Again, it's better to write it on a separate line, but you can do it in the same line. That's fine. Okay. So for readability. So if score is greater than 90, you can say cout you have an A. So that ends that if statement. And then here we can say else if the score is greater than or equal to, let's say, 80. And then we can write the other block and say cout you have a B. We can continue with this else if, or you can just end it if you want it. Okay, else if score is greater than or equal to 70, you have, let me try cout, right? You have a C. And then anything less than C, we can just end this and then write else. Else just cout. We're just ending the first if, so here we can just say else. You can write each one if you want it for D and for an F, whichever one. But we can just end it and say you have less than D. Okay. You can just end it, but you can continue if you wanted to until you get to F. Okay. So we run the program, and then it says enter your grade. Okay. Give me a grade. Huh? You said 60? Okay. So what did it say if we enter 60? You have less than? C. Okay, or we can run it again. So give me another grade.
84.
94?
84.
84, okay. What did it say?
You have a B.
You have a B. Okay, so you check each part. So let's say we have 91. Okay, you have an A. How about even if I put in the 90? What do you think will give us? It would give us A, because we are saying if the score is greater than or equal to 90. And again, you can just continue breaking this down until you get to the end. So you have if this equals, and then you can have the default at the end. So anytime you can continue, maybe add another one, and then when it's less than 60, you can say you failed. You can have that. Okay. Like for example, when you had, we can continue another if else statement, and then say if the score is greater than or equal to, what was the last one? So we can say 60 here. Then here we can say you have a D, right? Now here we can say else. Cout and then say you have failed the course. Okay. So now if you enter 59, it will say what? You have failed the course. Now earlier you told me you wanted to start with 60. Now if I put a 60 in, it will say you have. Oh, instead of you have less than, this should say you have. You have a D. All right. Okay. And we're gonna need an A there, right? An E there. Okay. Again, when you write these programs, don't lose points on what do you call, on documentation. Make sure you document your programs. All right. So you can write project, author, date, anything else you want to add. Testing, decision, selection structure. The date today. Time flies, huh? January 30. And then within each, you can write whatever you want to write. Okay?
The teacher required us to like comment each block and explain what you're doing.
So you have a choice of commenting, let's say, a block like this, and you can write the comment here and say this block of if statement is checking if the score is an A, something like that. That's fine. But once you did one of them, it's okay. Like you don't have to do each one of them. It can be overwhelming. You use it to explain something, specific function that's special, specific variable that we don't know what you're trying to do, then try to comment those. Does that make sense? And make sure you do have the actual problem you're trying to solve. If it's a problem you're reading it from the book, you can copy the actual problem there, and then type it as part of the requirement of that problem, and then your name and your date. Okay, that's fine. All right. Thank you. We'll end that, and then do you have any other lab due this week? It's just the first one that you have, or just the first one?
Yeah.
Okay. All right.